Hi, my name is Farzaneh Kazemzadeh and I want to speak about this paper. Solving the influence maximization problem by using entropy and weight of edges. At the first, I want to speak about the problem of influence maximization. This problem follows a cost set called S among the nodes of a community. This set is expected to have the highest diffusion with the highest influence capacity among other nodes. As you can see in the picture, there is a network and the influence maximization problem wants to find a set with conodes that have the maximum diffusion in the network. In most cases, the common models to calculating the influence spread have been independent cascade IC and linear threshold LT. IC model is used in the purposed algorithm. The purposed method. The difference between edges in social networks can be an important issue in solving the influence maximizing problem, which has been neglected in most articles. The EWIM algorithm paid special attention to the differences between the edges in the graph in terms of different topologies in social networks, including triangles, Jaccard index, and core number, to solve the IMP. It also determined their difference by focusing on entropy and calculating the right weight for each edge, and solve this problem in 3 steps: weighting to each edge, and total degree to the neighbor nodes, and also obtaining influential nodes. Step 1. Weighting to each edge. In this section, each edge weight W was calculated according to the Jaccard index in triangles and core number, and its relationship with set as follows. As you can see in this formula, where W, V, I, U, J is the weight for each edge, K, V, I shows the core number of the node Vi, and K, U, I stands for the core number. TRUI is the number of triangles, and finally CVIUJ shows Jaccard coefficient of the nodes Vi and Uj. And formula 2 is used to calculate the total weight of the edges that connect to around nodes. And as you can see in this formula, where WNVI is the weight of the edges around the node Vi and WVIUJ is the weight of the edges Vi and Uj. Step 2. Total degree of the neighbor nodes. Obtaining more influential nodes among the other nodes in a community is largely dependent on communication or its neighbors to other nodes. The communication rate of this node and its influence was somewhat determined by obtaining the total neighboring nodes V. This value was obtained in formula 3. And as you can see in formula 3, where DUJ indicates the degree of node UJ, neighbor nodes of VI. And in step 3, obtaining influential nodes. After making calculations on the edge and graph nodes and obtaining influential nodes, the number of K-nodes was identified as seed set according to SVI. As you can see in formula form, where SVI is the score of each node, the highest of which were selected as influential nodes of superspreaders. And then the nodes were sorted based on the obtained score, and K-nodes with the highest value were selected as seeds. About experiments. This section addresses the performed experiments and compares the algorithm with the CI, LIR, and PhD algorithms on QAIDA P150, P120, and email datasets to prove the efficiency of the EWIM algorithm. Experiments were conducted in the Python environment, and the IC influence spread model was used to obtain it. Moreover, to calculate the spread of influence, the probability of the influence spread was set to be P equals 0.02, and the calculations were made to detect spreaders set with size K equals 30 to create the most propagation in the entire network. The experiments to investigate the two criteria of diffusion and execution time are displayed on graphs. The rate of influence spread. Influence spread and seed set size of the EWIM algorithm with baseline algorithm on the graphs are shown by X and Y axes. Here the graphs of propagation are examined. In figure A indicates the implementation of the CI, LIR, PHG, and EWIM algorithms on the QAIDA network. Also, the EWIM algorithm has the best propagation among the CI, LIR, and PHG algorithms. The PHG algorithms is close to the proposed algorithm, but other algorithms are far away from it. Figure B depicts the email dataset. As shown by this figure, the algorithm in the lower nodes have provided almost similar results. LIR is much lower than the CI, PHG, and EWIM when there are more than 5 nodes. And also, Fig C indicates the P150 dataset. The proposed algorithm has the highest value, and both CI and PHG algorithms are placed at a distance from each other. The LIR algorithms can be seen at the bottom of the graph. Figure D demonstrates the implementation of the graph on the P120 dataset. Below the EWIM graph, the CI and PHG algorithm can be seen, and the LIR algorithm is displayed at the bottom of the graph. In all graphs, our proposed algorithm showed the highest spread of influence in social networks. The algorithm's runtime. Another important criterion that was investigated in the IMP is the execution time of the CI, LIR, and EWIM and PHG algorithm. This study tried to decline the execution time of the algorithm compared to other cases. As demonstrated in the table, CI and also PHG actually execution time is very high, and but LIR and EWIM execution time is much lower, as you can see here. Although the execution time of the LIR algorithm is lower than the proposed EWIM algorithm. This algorithm, LIR, exhibited a very low spread of influence according to the analysis of the spread of influence and its graphs. Therefore, it isn't an optional algorithm. Finally, the EWIM algorithm optimally solved this problem by relying on entropy and the differences between the edges in each graph in social networks. Applying the weight of the edges in performing calculation and expressing the importance of the degree is detecting influential nodes. The propagation result of the LIR, PHG, CI, and also EWIM algorithm indicates the EWIM efficiency to solve the IMP. Thus, it could be said that the IMP achieved super spreaders with the highest propagation in the community at the right time using the EWIM algorithm. This research has been done with the aim of achieving the highest level of penetration and implementing the algorithm in the shortest possible time. Finally, according to the graph and runtime table, this algorithm has been able to solve the needs in the best way. Thanks for your attention.